Welcome to the podcast, Koala Reading AI. I am your host and the voice behind the text-to-speech model. Get ready for an exciting journey through the world of computer vision. In today's episode, we have fascinating papers to discuss. Let's begin with a brief overview of each one. Paper 1. Vision Transformers Need Registers. This paper addresses artifacts in feature maps of ViT networks, proposing a solution involving additional tokens that not only resolves the issue, but also achieves state-of-the-art performance in self-supervised visual models and improves downstream visual processing. Paper 2. AUTOCLIP, Auto-Tuning Zero-Shot Classifiers for Vision Language Models. The paper presents AUTOCLIP, an unsupervised method for auto-tuning zero-shot classifiers based on vision language models like CLIP, significantly improving accuracy compared to traditional methods by assigning per-image weights to prompt templates. Paper 3. Emu, Enhancing Image Generation Models Using Photogenic Needles in a Haystack. Proposes a solution to enhance image generation models using quality tuning to generate highly aesthetic images while maintaining generality across visual concepts. Paper 4. DREAMGAUSSIAN, Generative Gaussian Splatting for Efficient 3D Content Creation. This paper presents DREAMGAUSSIAN, a novel 3D content generation framework that efficiently produces high-quality textured meshes, achieving approximately 10 times faster results compared to existing methods, making it highly practical for single-view image-based 3D content creation. Now that we have an overview of these exciting papers, let's take a deep dive into each one. We'll explore the abstract methodology and key results of each paper. Paper 1. Vision Transformers Need Registers. Abstract. The paper proposes a simple yet effective solution to improve the performance of vision transformers by introducing register tokens. The authors demonstrate that adding register tokens to the transformer architecture can significantly improve the quality of local feature maps, leading to better performance on downstream tasks. The proposed method is evaluated on 3 different state-of-the-art training methods for supervised, text-supervised, and unsupervised learning, and it consistently outperforms the baseline models. Additionally, the authors show that the use of register tokens can also improve the performance of unsupervised object discovery methods. Method. The proposed method introduces register tokens to the transformer architecture, which are used to store information about the input image. The register tokens are added to the input sequence and are processed by the transformer along with the other tokens. The authors demonstrate that the use of register tokens can significantly improve the quality of local feature maps, leading to better performance on downstream tasks. The authors also show that the use of register tokens can help alleviate the performance regression observed when applying unsupervised object discovery methods to modern backbones, such as DNOV2 or supervised ones. Results. The proposed method is evaluated on 3 different state-of-the-art training methods for supervised, text-supervised, and unsupervised learning. The authors demonstrate that the use of register tokens consistently outperforms the baseline models on all 3 training methods. The authors also show that the use of register tokens can improve the performance of unsupervised object discovery methods. The authors provide examples of use cases for this new paper, including image classification and object detection. The authors demonstrate that the use of register tokens can improve the performance of these tasks, leading to better accuracy and faster convergence. Overall, the proposed method is a simple yet effective solution to improve the performance of vision transformers, and it has the potential to be widely adopted in the computer vision community. Paper 2. AUTOCLIP, Auto-Tuning Zero-Shot Classifiers for Vision Language Models. Abstract. The paper presents a new method for improving the performance of zero-shot classifiers for vision language models. The method, called AUTOCLIP, allows for the automatic tuning of prompt templates, which are used to generate image descriptions for classification. The authors compare 3 different ways of generating prompt templates and show that AUTOCLIP outperforms the baseline in 85% of cases. The results indicate that AUTOCLIP benefits from larger and more diverse sets of prompt templates. Method. The innovation of AUTOCLIP lies in its ability to automatically tune prompt templates for zero-shot classifiers. Prompt templates are used to generate image descriptions that are then used for classification. The authors compare 3 different ways of generating prompt templates: using manually designed templates, querying a large language model, and appending random words or characters to predefined prompt templates. They then use AUTOCLIP to assign weights to each prompt template per image, which allows for more accurate classification. The authors report results averaged over 7 runs to account for randomness in the template construction sampling. Results. The results of the study show that AUTOCLIP outperforms the baseline in 85% of cases. The authors observe a trend that for larger numbers of prompt templates, the advantage of AUTOCLIP increases. When aggregating over models, datasets, and number of prompt templates, AUTOCLIP achieves the largest average improvement for WaffleClip, but still improves for Clip and Declip. The findings indicate that AUTOCLIP benefits from larger and more diverse sets of prompt templates. The authors provide examples of use cases for AUTOCLIP, such as image classification for medical diagnosis and object recognition for autonomous vehicles. They also highlight the innovation of AUTOCLIP, which allows for the automatic tuning of prompt templates, making the classification process more accurate and efficient. Overall, the study demonstrates the effectiveness of AUTOCLIP in improving the performance of zero-shot classifiers for vision language models. Paper 3. Emu Enhancing Image Generation Models Using Photogenic Needles in a Haystack. Abstract. The paper introduces Emu, a novel approach to enhance image generation models using photogenic needles in a haystack. Emu utilizes quality tuning to generate highly aesthetic images while maintaining generality across visual concepts. The proposed method is evaluated on 2 datasets, and the results show that Emu outperforms state-of-the-art models in terms of both quantitative and qualitative metrics. The paper also discusses the limitations of the proposed method and suggests future directions for research. Method. Emu is a 2-stage approach that combines pre-training and quality tuning. In the pre-training stage, a generative model is trained on a large dataset of images to learn the underlying distribution of visual concepts. In the quality tuning stage, Emu uses a small set of high-quality images as photogenic needles to guide the generative model towards generating more aesthetically pleasing images. The photogenic needles are selected based on their adherence to certain principles of professional photography composition, lighting, color and contrast, and subject and background. Emu introduces several innovations to the quality tuning process. First, it uses a novel sampling strategy that balances the importance of the photogenic needles and the underlying distribution of visual concepts. Second, it employs a multi-objective optimization approach that simultaneously maximizes both the aesthetic quality and the diversity of the generated images. Third, it introduces a new metric for evaluating the aesthetic quality of the generated images, which is based on human evaluation and takes into account the principles of professional photography composition, lighting, color and contrast, and subject and background. Results. The proposed method is evaluated on 2 datasets, party and open user input, using both quantitative and qualitative metrics. The results show that Emu outperforms state-of-the-art models in terms of both the aesthetic quality and the diversity of the generated images. Emu also achieves a higher human evaluation score than the baseline models, indicating that it generates more aesthetically pleasing images. The paper provides several examples of use cases for Emu, such as generating realistic images for virtual reality applications, creating art for digital media, and generating images for e-commerce websites. Paper 4. DreamGaussian, Generative Gaussian Splatting for Efficient 3D Content Creation. Abstract. DreamGaussian is a 3D content generation framework that significantly improves the efficiency of 3D content creation. Our work proposes a generative Gaussian splatting pipeline that is highly efficient for 3D generation. We also introduce a mesh extraction algorithm that effectively derives textured meshes from 3D Gaussians. With our texture fine-tuning stage, our work can produce ready-to-use 3D assets with high-quality polygonal meshes from either a single image or text description within a few minutes. Our approach is innovative in that it addresses common problems with previous text-to-3D works, such as the multi-face Janus problem and baked lighting, with recent advances in multi-view 2D diffusion models and latent BRDF autoencoder. Method. Our approach to 3D content generation is based on a two-stage framework for efficient 3D content generation for both image-to-3D and text-to-3D tasks. Firstly, we adapt 3D Gaussian splatting, which is a generative model that uses a Gaussian distribution to represent the 3D shape of an object. We propose a generative Gaussian splatting pipeline that is highly efficient for 3D generation. This pipeline allows for faster convergence and better texture refinement, which results in high-quality polygonal meshes. Secondly, we introduce a mesh extraction algorithm that effectively derives textured meshes from 3D Gaussians. This algorithm is designed to extract the most important features of the 3D Gaussian distribution and convert them into a textured mesh. With our texture fine-tuning stage, our work can produce ready-to-use 3D assets with high-quality polygonal meshes from either a single image or text description within a few minutes. Results. Our approach to 3D content generation has several use cases, including video game development, virtual reality, and 3D printing. Our work is innovative in that it addresses common problems with previous text-to-3D works, such as the multi-face Janus problem and baked lighting, with recent advances in multi-view 2D diffusion models and latent BRDF autoencoder. We demonstrate the effectiveness of our approach in Figure 11, where we show the text-to-image-to-3D pipeline. We first apply text-to-image diffusion models to synthesize an image given a text prompt, then perform image-to-3D using our model. This usually gives better results compared to directly performing text-to-3D pipeline and takes less time to generate. Thank you for listening to Koala Reading AI. Hope you had fun.